Eric Burgess here, and we have been asked what is the difference between a sequence and a series. So they're pretty related. A sequence is easy enough. A sequence, we usually write it as A sub n, and it is a list of elements in an order. So we have a first element, we have a second element, we have a third element, a fourth element. That's all it is. And then we keep going on and on and on until we reach the nth element. So it's just a bunch of elements in an order. That is all a sequence is. So a sequence is really easy to understand. It's kind of what we expect it. A series is what we do with a sequence. So let's start with partial sums. So we would write a series as Sn, okay? But just kind of ignore it for now. Just think, okay, Sn. It looks very similar to what an, right? We use the same subscript. And so if we take the elements of a sequence, for example, a1, that's the first partial sum of the series. If we were to go again and we go s2, that's going to be the first element plus the second element. S3 is the first element plus the second element plus the third element, and it goes on and on and on until you get to Sn. This is the series. So you can see that these numbers right here, they produce a sequence. And we just give this sequence a special name since it's got all these plus signs since we're adding elements. When we add n elements, meaning an infinite number of elements together, we arrive at the at the series Sn. So it can be a little confusing because you might think, oh, but this is just a new sequence. But this sequence has a special name. It's called a series because we're adding everything together. It's called an infinite series because there's an infinite number of terms. And these middle bits here are called the partial sums. And we can use those to hopefully deduce things about the series. So that's how these two are different. And it should be noted, right? If a series has a finite number, and we could do this, we can find the sum of a series. So check this out. So this is just a sequence, right? And we've already learned a bunch about sequences. So if we could say Sn, if the limit as Sn, or we could just say n, as n goes to infinity of Sn is equal to some number, well, this is the same thing, right? We already have essentially a sequence. And so we could say if that's equal to some number, well, then it's got to converge. This sum has to be a finite number because whatever this limit is, as we add more and more terms, they're going to approach a definitive number. But if we take the limit and it ends up being that the numbers go and go and go without ever stopping, the limit has no, it just is infinity. There's no finite number. Well, then we say it's divergent. And so you could do things with the series, say things about the series by looking at what the series is doing. And the series itself is basically just a special sequence. So you're going to hear the word series pretty much from now on because we're very interested in what this is doing. Sequences, whenever they bring it up, they're just mentioning a list of elements in an order. And the series is what happens when you start adding those elements together. And they allow you to say things about bigger behaviors. And when you get later on into later classes, just to sort of motivate you to learn more, to pay attention to this, it becomes extremely useful. There are some questions once you get into differential equations, and in engineering, it's very common to use series to take functions that would be very complicated and simplify them to just the first few terms. So that is a sequence and that is a series. If you have any questions about this, feel free to drop them in the comments down below. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.